Happy Halloween, everybody. We're talking today about using AI to rate pictures of pumpkins and how to evaluate such an AI tool. We've got a pumpkin rater right here, which we'll get back into in a second. But the first thing we need to do if we want to rate some pictures is to generate some pictures. We built a pipeline, and so we're going to generate prompts that are scary or not scary, conventional or creative, high degree of skill or sloppy. We're going to put them into an Anthropic Claude model and have it generate fancy prompts. Then pipe those into the image generation model and then get our images. So if we run all of that code, we can look at a prompt. This is for a scary, high quality one, menacing jack-o'-lantern with triangular eyes, etc. And we can run that prompt through our diffusion model and we get a very scary picture of a pumpkin. That's at very high quality. And so we do this dozens of times and we've got ourselves a test data set. Going over here now, our rater is going to comment on the originality, the skill, the scariness of the pumpkins, and it also throws in a short story about that pumpkin just for fun. It uses the image analysis features of OpenAI and Anthropic's AI models, load in our test set, plot one of the pumpkins that we generated, and then run the rater. And we get these nice descriptions here showing the originality, the skill, the scariness, and comments about each. And it goes into quite a bit of detail. Here it thought it was original, skillful, and scary, so that's good because that's what it was supposed to be. So here's how we evaluate the models. We write a describe image function here, which generates for us a detailed description of each image. So this has nothing to do with the ratings. This is a ground truth detailed description of each image. Then remember that our model is making comments about the originality, comments about the skill, comments about the scariness. What we're going to do is we're going to use RAGAS metrics, which are scores usually used in assessing RAG systems, to see how well those comments match the detailed description, which we're treating as the ground truth for that image. We run through that test here, and using the RAGAS library, we get these ratings, which we can plot into a chart. It's called a faithfulness score, but it shows how well the comments are supported by description. We see the scores are quite good. In general, it's pretty much a tie, with OpenAI slightly edging out Anthropic when we compare the two models, except for on the skill column, where for some reason there was a much bigger gap. And then the other way that we can assess them is by comparing the ground truth, or what we used to generate. So was it not at all scary? Was it scary? Was it conventional? Or was it creative? We can assign labels to those, and we can see how those scores compare with the score that was actually given. We can look at the ground truth label, either a 1 or a 5, versus the label assigned by the model, and we can see how well they correlate. And so when we compare them for the two different models, for the 3 different characteristics, we see very good correlation for the scariness, less so for the originality, but still some signal, and then not so much for the skill. So that's an interesting finding, that the model is actually better at finding some characteristics than it is at finding other characteristics. And that may be due, for example, to ambiguity in the way that we've prompted it. So that's all we've had for you today. We have built a pipeline for generating and rating pumpkin images, and then we've built a secondary evaluation protocol for looking at how well the rater does. Wishing everybody a happy Halloween.